What we're going to start off with this week is just a very small analysis tool where I'm going to give you a visual way of checking whether or not you're meeting some of your design goals. So for instance, if you're creating a circle pattern over a surface and your goal is to eliminate a certain percentage of sunlight that's getting in through that surface, then I'm just going to show you a mathematical operator and a color signifier that's going to show you kind of where the ticket is for that. The other thing is I'm going to show you a little bit about deconstructing geometry a bit further and isolating particular components so that you can reconstruct them into other types of components, basically. And I might get into rotations. Rotations are very important, I think, for what we do. So hopefully we'll be able to get there today. Basically, what I want to get to, the state I want to be in by the end of, not today, but the next probably day or two of exploring this kind of thing, is I want you to be able to just know how to deconstruct many different types of geometry, how to build it up using different operations. So I already showed you something that simulates an array. I showed you how to eliminate with a pattern or a sequence, and so I'm going to show you how you can do rotations and vary those rotations and stuff like that. So, so starting off, I just want to give you that mathematical operator here, and to do that, I'm going to go back to, and you don't have to go back to this. In fact, well, actually, this one you don't necessarily have to follow along with. Just know that you can do it this way and where to find my video once I'm done. But if you do have this open and you are choosing to do all of your definitions in one, I'm going back to the original perforated panel that I created previously. So if you recall, the perforated panel looks like this, and it has a pattern already built into it. It has an extrusion that we created, so I need to follow the extrusion back to the point where it's simply a surface, not an extrusion, because I'm going to use the remaining area of the surface to test against the original area of my glazing. Okay, so let's say the scenario is this. You want to, and let me turn this layer off real fast, hold on. So your goal is to block out 45% of the sunlight that gets into this space. And you're choosing to do that with a perforated panel. That's all well and good. You just need to verify that it is 45% of that. Now there are two ways. The one way would be to just put a mathematical operator on it and visually look for when it drops below 45 or 0.45. And the other way would be to, if you're going to be, bumping the sliders back and forth all the time, you put a mesh color on it so that it basically just paints it a certain color when it is below 45. So let's do that real fast. So we're basically comparing the two areas. So I'm going to do it this way, and let me pull this off to the side, and we're going to jump kind of down and create a branch here. And I'm going to do that with my surface analysis area. So now we're actually using the area tool to measure area, finally. And we plug in the surface difference to that. So it gives us a, that's coincidence, it gives us an area of 45. That's not a percentage, that's just the area of square feet that this perforated panel takes up. So we also have to measure the original surface of the glazing, and to do that I'm going to reference in that surface, and I'm going to do it using a surface param, and I'll just right click it and set one surface, and I'll click did it give me all of them? Yeah, it did. I'll need to explode it and set the front surface. I do want to take a quick moment to kind of step aside and say it's usually not the best idea to explode your poly surfaces. And when I get to the element isolation section later on today, you'll see how to do it without exploding. But right now, that's all we know how to do, so we'll do it. All right. So then we can take an area again and measure the surface of the original glazing. And the area of the original glazing is 128 square feet. So how do we find the percentage? So really all we have to do is divide one number by the other and we'll find out what the percentage of square footage is. If we go up to math and operators, we can use division. And if we do the testing square footage against the original and divide it by the original square footage, we get the percentage. So I'll do 45, I'll get rid of that panel, and 128, and I'll move this panel over here. So now 45 divided by 128 is 0.35. So that means that the square footage of the perforated panel that I've created only covers 35% or 35.7% of my surface. Making a little bit of sense? All right, so now here's what we do to change it, okay? And make it visual, right? This is option one. You can just look at this panel all day and verify it that way. The other option is to make it visual, and it also helps for when you're proving your actual analysis in graphic methods too. You can use this to produce graphics. So I'm going to leave that panel there. We have a tool that's called mesh colors, and you can convert surfaces to meshes and then apply a pretty nifty, very simple color to it. We will have to create a testing number, and then we're going to split a list based on whether or not it meets the criteria or does not. The way that I describe this in my classes usually is that it's kind of like a light switch, and it has a number threshold where it switches the light on when it hits that number or is above or below that number. So we're going to use under math and operators, we're going to use either larger than or smaller than. Doesn't really matter which one we use as long as we know how we're using them in that case. So since I'm trying to make a panel that is larger than a certain number, I'm going to use larger than. And its description basically says that you plug in a number to test, and then you plug in a testing number or a test against number. And so it'll take this 0.35 and it will test against what we tell it wants to measure against. So basically our threshold. So I'll put a panel in here for 0.45 since I want to be 45% covered. And I plug that in. So what does it do? The result is a Boolean output. A Boolean output means that it has either a yes or a no, or a true or a false, or a 0 or a 1. They're all kind of interchangeable. So in this case, 0.35 is not larger than 0.45. Coincidentally, it's also not larger than or equal to. If we were to use, and I'm just going to throw this in there just to show you, if we were to use smaller than and plug it in the same way, you'll see that it's actually true now, because 0.35 is smaller than 0.45. I'm exhausting you with my explanations, but I think it's important to know. So, so now we have a Boolean output which can be used as a filter. That's what's really cool about this, is that when we can switch between the two, whether it's true or false, we can feed our list, basically our surface, through and then change the direction via like a branching mechanism. You know, you can either connect to one circuit, or you can connect off to a different circuit. And that's called, it's under, actually let me get this in here. And that's under the set tab, under the tree. Is it under tree? What am I thinking of? No, I'm sorry, it's under list. Yeah, set and list, and it's called dispatch. So now dispatch is going to split it into 2 target lists, but we're only going to give it 1 list. So this is what it's going to look like. The list is going to be the surface of the panel. So I'm going to render it in a certain color if it's good and it is more than 45% covering the glazing. And then I'm going to render it a different color if it's not. So the list that's going to plug in, the L input, is going to be the surface difference. So I'll take that down here. And then the pattern. So a dispatch pattern basically is going to take a Boolean mask. Think of it as a mask, right? It's going to kind of overlay the Booleans over top of the list, and it's going to filter out the ones that either match or don't match. So the larger than test gets plugged in to P, and in fact I probably want to use larger than or equal to because my criteria is 0.45 or more. So what it says is, what are we getting? Ah, yes. So our output right now reads false. So the A, right, this is the dispatch target for true values. Anything in your list that is true in this case is going to get filtered through A. Anything that's false is going to get filtered through B. And that's where you see now our trimmed surface has filtered into leg B. So here's the really cool part. I can set up the colors. Let me get this going here. I can set up the colors by going to Mesh and Mesh Colors. I might need to convert it to a mesh first. Yeah, I think I need to convert it. I believe so, yeah. So let me try Mesh Colors first. It might make me convert it, but anyway, let me see. Oh, it did. Okay, so I don't need to convert it. Anyway, so under Mesh and Primitive, Mesh Colors is going to request obviously a mesh, but in this case it automatically converts our surface to a mesh, so that's okay. The other thing that we want to do is go back to params, and we're going to select a color swatch. So anytime a surface is fed into this mesh colors, it's going to be rendered in this particular color. So params, and under input, we're going to use a color swatch. So if I plug the white swatch into the mesh colors, it shows up as white. Pretty cool so far, right? So then here's the really cool part. I copy and paste this up, and I plug it into the A output, and I'll change the color. Actually, I'll change my B output, which is false, to red, because that's bad. And I'll change my, I'll just leave the good output at white. So anytime my perforated panel is covering more than 45% of the glazing, it'll be white. Anytime it's less than, it'll be red. So all I have to do now, this is the really, really easy and simple and cool part, is modify my pattern to make it so that it covers 45%. So there are many ways I could do that, but the one I'm just going to choose is to stretch the panel upward. It's going to be the most direct route right now. So if I, am I in Rhino here? Yeah. Control Shift. Oh, I have it off. Hold on. So if I just grab the original surface and I stretch it up, I don't know, 2 feet, it's going to recalculate, and it'll tell me whether or not now it's covering 45% of the glazing. And you see it turned white, so that tells me that it is covering more than 45%. Where are we here? Oop, keeps minimizing on screen too. Hang on. Okay, so basically what happened was now via our mathematical operator, it's covering 60.7% of that perforated panel. Okay, so if you're doing a lot of active modeling and you're just basically testing for certain parameters, you can use this as a visual means of kind of just giving you a trigger that says, okay, yes, it is good. It's covering more than 45%. So what questions do you have? None? How many of you followed along?
I tried to.
It's okay. I know I went a little fast on that one, but yeah. All right. I'll walk you through it again when I stop here.